In this video, we are going to focus on Common Core math, and we're going to touch on these four areas: addition, subtraction, multiplication, and division. Now, the basic idea behind Common Core math is not just knowing what to do in order to solve a problem, but understanding how to do it and knowing why it works the way it does. And so that's what we're going to focus on in this video. We are going to understand the principles behind addition, subtraction, multiplication, and division. Because knowledge comes easy to the person with understanding. And so we want to develop an understanding of these basic principles of math. And if you have that, then learning harder topics can become easier to you. Let's begin our discussion with addition. Let's say if we wish to add 7 and 5 together. Now, chances are you already know the answer, but when you're adding small numbers, if you wish to conceptualize it, it helps to draw a number line. Let's put 0 over here. And let's say 7 is to the right of 0. Whenever you're adding, you need to travel to the right of the number line. If you wish to subtract, travel to the left. So 7 plus 5. The way to get the answer using the number line, start with the first number 7, and then add 5 to it, or travel 5 units to the right. So this would be 8, 9, 10, 11, 12. So 7 plus 5 is 12. And so that's one way in which you can conceptualize addition. Try these two examples using number lines. Add 3 and 6, and also -4 and 7. So let's start with the first number, 3. Now we're going to add 6 to it. So let's travel 6 units to the right from the number 3. 1, 2, 3, 4, 5, 6. So this is 4, 5, 6, 7, 8, 9. So 9 is where we end, which means 3 plus 6 is equal to 9. Now for the example below, let's start with -4, which is going to be, let's put 0 in the middle this time. So here's -4. Now we're adding 7 to it, so let's travel 7 units to the right. 1, 2, 3, 4, 5, 6, 7. So this is -3, -2, -1, 0, 1, 2, and 3. So -4 plus 7 is 3. And so that's how you can add simple numbers using a number line. Now let's perform addition using Common Core standards. So let's say if we wish to add 7 and 6 without the use of a number line or a calculator. What can we do? Well, one thing you could do is you could basically take a number and decompose it into different parts, which may make the problem easier. For instance, 6, we can write 6 as being 3 plus 3. 3 plus 3 is 6. Now notice what 7 plus 3 is. It's easy to see that 7 plus 3 is 10. And 10 plus 3 is 13. So 6 plus 7, or 7 plus 6, is 13. And so that's another way to think about addition. Let's say if you wish to add up numbers mentally in your head, it's easy when dealing with powers of 10 or base 10. And so this is one way you can add numbers. Let's try another example. Let's add 16 plus 9. Now, if you don't know what 16 plus 9 is mentally in your head, you can break it down this way. So let's break down 9 into two numbers, one of which, when we add it to 16, will give us 20. You can think of 9 as being 4 plus 5. And now, if we focus on adding 16 and 4, that's going to give us 20. And now it's easy to see that 20 plus 5 is 25. And so that's one way you can apply Common Core standards when dealing with addition. Let's do another example for the sake of practice. Let's add 28 and 6. So let's break down 6 into 2 and 4. Now we know that 28 plus 2 is 30. And so 30 plus 4 is 34. Now let's work on an example with larger numbers. Let's add 76 and 47. So what we're going to do is we're going to add them using the old school method. So let's line it up first. Let's begin by adding the first column of numbers on the right. 6 plus 7 is 13. So we need to write the 3 and carry over the 1. Next, let's add the column of numbers on the left. 1 plus 7 is 8, 8 plus 4 is 12. And so this gives us 123. And this is a very simple way in which we can perform addition. It's very effective. However, it doesn't help us to understand why addition works the way it does. It tells us what to do, but it doesn't help us to understand how it works. And so that's the basic idea behind Common Core Math, is that you want to understand what you're doing rather than just knowing what to do. So here's one way of looking at this. Let me get rid of this one. 6 is in a ones place and 7 is in a tens place. So the 6 really means a 6. The 7 is not really 7, but it's really 70. So you got to think of 76 as being 70 plus 6. 47 is really 40 plus 7. Now, if you add 6 and 7, that will give you 13. And if you add 70 and 40, that gives you 110. Now, 110 plus 13. If you're not sure, you could think of 13 as being 10 plus 3. And so 110 plus 10 is 120. 120 plus 3 is 123. So when looking at these numbers here, you need to realize that the 7 is 70, the 4 is 40. And so it helps you to understand what your final result will be. Now let's talk about other ways in which we can add this, particularly if you want to do it mentally. So using the method that we were doing before, we can write 76 as being 70 plus 6, 47 as being 40 plus 7. So now if we focus on these two, 70 plus 40, that is 130, because, that's 110. 7 plus 4 is 11. So 70 plus 40 is 110, just add the 0. And then 6 plus 7 is 13. So 110 plus 13 is 123. Let's try a harder example. Go ahead and add 135 and 98. Try to do so mentally by regrouping numbers. And then you could check your work by doing it the old school way, using a paper and a pen or pencil. Now, I'm going to break down 135 as being 100 plus 30 plus 5. 98, I'm going to leave it the way it is, and you'll see why. Now, the 5, I'm going to write it as 3 plus 2. 3 plus 2 is 5. Notice that I can easily add these two numbers now. 2 plus 98 is 100. So I have 100, and then I have the 100 here, which I'm just going to write it in the second place, and then 30 plus 3. Now 100 plus 100 is 200. And 30 plus 3 is 33. And then 200 plus 33 gives us the answer 233. So let's conceptualize what we've done here. Basically, I've taken 2 from 135 and added it to 98. So let's decrease this number by 2. 135 minus 2 is 133. And then 98 plus 2 is 100. So by transferring 2, this problem becomes a lot easier. So it's 133 plus 100, which is 233. And if you could move around numbers like that, it makes addition a lot more simple. And so it becomes easy to do mental math in your head. Let's try another example. So let's say if I have 247 plus 95. So I want to turn this into 100. What I'm going to do is I'm going to take away 5 from 247 and transfer it to 95. So if you decrease this by 5, that becomes 242. And if you increase this by 5, that's 100. So 242 plus 100 is 342. And there's so many ways in which you can regroup numbers, but the key is to understand what you're doing, and so that you can quickly get the answer mentally in your head. Now let's confirm the answer to the last problem using the old school method. So let's begin by adding 7 and 5. 7 plus 5 is 12. So let's write the 2, carry over the 1. Now let's add these three numbers. It's easier if we add 1 and 9 first. 1 plus 9 is 10, and then 10 plus 4 is 14. So let's write the 4, carry over the 1, and 1 plus 2 is 3. And so as you can see, we get the same answer, 342. But now you know how to do a problem like this mentally in your head. Now let's move on to the next topic, and that is subtraction. So let's say if we wish to subtract 9 by 5. If it's simple like this, you could use a number line, just like we talked about before. So let's just put 9 somewhere on the number line. Now we're subtracting it by 5. When you subtract, you need to travel to the left side. Remember, if you're adding, you need to travel to the right side. So just keep that in mind. So to subtract 9 by 5, we need to travel 5 units to the left. 1, 2, 3, 4, 5. So this is 8, 7, 6, 5, 4. Thus 9 minus 5 is 4. Try these two examples using a number line. Subtract 6 by 9 and negative 4 by positive 8. So starting with the first example, let's place 6 somewhere on the right, and then let's travel 9 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now let's count down. This is 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. So 6 minus 9 is negative 3. But now you understand why this is the answer. You don't simply have to memorize that 6 minus 9 is negative 3. Using a number line, you understand a reason for the answer. Now let's try the next example. So let's start with negative 4, and we're going to travel 8 units to the left. 1, 2, 3, 4, 5, 6, 7, 8. So this is negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12. So negative 4 minus 8 is equal to negative 12. And so using a number line, now you know how to add or subtract integers. And you also understand why the answer is the way it is. Now let's work on bigger numbers. Let's say if we wish to subtract 36 by 17. What would you do? Let's think about it mentally. How would you rearrange these numbers to accomplish this result? There's different ways of doing this. 36, we can write that as 30 plus 6. 17 is basically, you could say 10 plus 7. Now we do need to distribute the negative sign. So we have 30 plus 6 minus 10 plus or minus 7 if you distribute the negative to the positive 7. Now 30 minus 10 is 20. And then 6 plus negative 7, or 6 minus 7, is negative 1. And so 20 minus 1 is 19. So this is one way in which you can do it. Now perhaps you're thinking, man, this is just too long to do it this way. There are many other ways in which you can regroup these numbers. And the key is just to pick a way that you're familiar with, and that's very easy for you to do. One way that I'm thinking of is I can write negative 17 as being negative 16 minus 1. Because now it's easy to subtract 36 by 16. 3 minus 1 is 2, and 6 minus 6 is 0. So 36 minus 16 is 20. And then you have 20 minus 1, which is 19. And doing it that way was a lot easier than the other way, but it all depends on how you regroup it. And with practice, you can become very good at doing mental math. So in my mind, that's how I would subtract 36 by 17. First, I will subtract 36 by 16, take it down to 20, and then subtract 20 by 1, which will give me 19. So you can think of subtraction as a series of steps. Now, let's subtract those two numbers using the old school way. The first thing we're going to do is we're going to subtract 6 by 7. Now that gives us a negative number, so we can't do that. So what we're going to have to do is borrow a 1 from 3. The 3 becomes 2, and 6 turns into 16. So now we can subtract 16 by 7. 16 minus 7, using a number line, is 9. Now, if you don't want to use a number line, think about it this way. So first, subtract 16 by 6, and then by 1. 16 minus 6 is 10. 10 minus 1 is 9. Now, we have 2 minus 1, which is 1. And so this gives us the same result of 19. Now, let's try a similar example. Subtract 43 by 19 by regrouping, by using the old school method, and we're also going to talk about another way of doing this, to conceptualize subtraction. So take a minute and work on that example. So what do you recommend that we should do? How should we regroup this, so to speak? Now, what I'm thinking of doing is this. There's other ways to do this. You could say 40 plus 3 minus 10 minus 9. That's one way, but that's a lot of numbers. What I'm going to do is I'm going to break down 43 into 20 and 23, because it's relatively easy to see that 20 plus 23 is 43. But I want to write the 23 first. So I'm going to write it as 23 plus 20. Now the 19, I'm going to leave it the way it is. So as you can see, it's easy to perform this operation. 20 minus 19 is 1. And so all we have left over is 23 plus 1, which is 24. And that's not bad. So that's a very simple way to do subtraction if you break it up in a nice, easy way, or where it's easy to do the problem. Now let's confirm our answer of 24 using the old school method. So let's subtract 43 by 19. So we can't do 3 minus 9 because we get a negative result. So let's borrow a 1 from the 4. So the 4 becomes a 3, and the 3 turns into 13. Now 13 minus 9. So let's do that in our heads. Let's think of 13 as being 3 plus 10. Now 10 minus 9 is 1. So we have 3 plus 1, which is 4. Thus, 13 minus 9 is 4. And then we have 3 minus 1, which is 2. So we get the same answer of 24. Now let's use another method to get the same answer. And we're going to use a number line. So we wish to subtract 43 by 19. Let's write those two numbers. Let's write the smaller number on the left and the larger number on the right. So you could think of subtraction as being the distance between 2 points on a number line. So how many units do we have to travel to go from 19 to 43. Well, let's break it down into parts. The next best number to write, going from 19 to 43, is 20. And then we could skip from 20 to 40, and then 40 to 43. So to go from 19 to 20, we need to travel 1 unit. Now, to go from 20 to 40, we need to travel 20 units. And then to go from 40 to 43, we need to travel 3 units. So let's add up these numbers. 1 plus 20, which is 21, plus 3, that's 24. And so that's another way in which you could perform subtraction. It's by counting up from the smallest number to the largest number. Now let's work on another example. But let's use a bigger number. Let's subtract 342 by 79. So I want you to use all 3 methods. Try to do it mentally in your head by regrouping, and then try to do it using the old school method and using the number line that we've just discussed. So let's talk about regrouping. So how should we do this? What is the best way that we can regroup these numbers so that we can easily subtract 342 by 79? Well, first, what I'm going to do is I'm going to write 342 as being 342. Now, 79 is basically 42 and 37. The reason why is 4 plus 3 is 7, and 2 plus 7 is 9. So 42 plus 37 is 79. Hopefully you see it that way. Now let's distribute the negative sign. So negative 79 is basically negative 42 minus 37. Now notice that I can cancel these two. 42 minus 42 is 0. So I've simplified my problem to being 300 minus 37. So now what do you think I should do next? What do you recommend? So 300, we can write that as 200 plus 100. And 37, I'm going to write that as 30 and 7. So negative 37 is negative 30 minus 7. 100 minus 30 is 70. So now I have this. Now 70 minus 7, we could just do that. That's just 63. So this becomes 200 plus 63. So our final answer is 263. Now I think I know what you might be thinking, and that is this is a very long way to do this problem. And you're right. Chances are we could find another way to regroup these numbers to make it more simple. And let's see what we can do. So instead of breaking 79 into 2 smaller numbers, let's break down 342 into 2 numbers. So let's write 342 as 242 plus 100. Perhaps this is going to be a lot, or just more simpler. Now, what is 100 minus 79? If you're not sure, let's write 100 as being 20 plus 80. Now, it's very easy to see what 80 minus 79 is because they're only 1 unit apart from each other in the number line. 80 minus 79 is 1. So now it's easier to do what we have now. 242 plus 20 is 262. And 262 plus 1 is 263. So doing it this way was a lot simpler than the other way. But it really all depends on how you view it and which approach you want to take. There's more than one way. Now let's use the old school method of subtraction to get the answer. So let's line up the numbers first. Now, 2 minus 9 will give us a negative number. So let's borrow a 1. The 4 is going to become a 3, and the 2 will become 12. Now, 12 minus 9. Using a number line, we know that's going to be 3. And we can't do 3 minus 7. That's a negative number. That's a negative 4. So let's borrow a 1 from the 3. That becomes a 2, and the 3 becomes a 13. So what is 13 minus 7? Well, let's think about that. So 13 is going to be 3 plus 10. And 10 minus 7 is 3. 3 plus 3 is 6. So 13 minus 7 is 6. And now 2 minus nothing is 2. So we get the same answer of 263. Now let's use the other technique. Let's draw a number line, and let's start with the lowest number, which is 79, and let's count up to the highest number, which is 342. Now, let's go from 79 to 80, and then 80 to 100, and then 100 to, let's say, 300, and then 300 to 340, and then to 342. So going from 79 to 80, that's only 1 unit. And then going from 80 to 100, that's 20 units to the right. Then going from 100 to 300, that's going to be 200 units. And then 300 to 340, that's 40 units. And finally, 340 to 342, that's going to be 2 units apart. So now let's add. So adding 20 and 40 is 60. 60 plus 200, that's 260. 1 plus 2 is 3. So 260 plus 3 gives us 263. And so there's many different techniques in which you can employ when dealing with subtraction. But one simple way is to think about how far is 79 from 342 in a number line. That's how you can conceptualize it, if you wish to do so. Now let's move on to multiplication. What really is multiplication? Let's use 4 times 3 as an example. Now we know that 4 times 3 is 12, but why? Why is it 12? It's important to understand that multiplication is basically repeat addition. So 4 times 3, this is basically you're adding 3 4 times. So it's 3 plus 3 plus 3 plus 3. 3 plus 3 is 6. And so this is equal to 6, that's equal to 6, and 6 plus 6 is 12. Thus 4 times 3 is equal to 12. You can also set it up the reverse way, 3 times 4. So basically you're adding 4 3 times. 4 plus 4 is 8, 8 plus 4 is 12. And so that's the basic idea behind multiplication. It's repeat addition. So let's say if we wish to multiply 6 by 4. So you can add up 4 6 times, or you can add up 6 4 times. It's easier to add up 6 4 times. 6 plus 6 adds up to 12. And so we're going to have 12 plus 12, which is 24. And so 6 times 4 is 24. Let's try another example. What is 13 times 6? Go ahead and work on that example. So we can add up 6 13 times, or we can add 13 6 times. And I think it's better to add up 13 6 times. Now, adding 2 13s together will give us 26. And thus we have 3 pairs of 2s, or 3 pairs of 13. So this is going to be 26 plus 26 plus 26. 26 plus 26 is 52. And 52 plus 26, that's going to be 78. So therefore, 13 times 6 is 78. Now sometimes you might have large numbers to deal with. For instance, let's say if we wish to multiply 29 by 36. In this case, you don't want to add up 36 29 times, or add up 29 36 times. That's going to just be too much work, so there has to be an easier way of doing this. Well, let's talk about the old school method. Let's write it this way. 6 times 9 is 54. So we're going to write the 4, carry over the 5. 9 times 3 is 27, and then you got to add 5, which is 32. Now, let's move on to the next number 2. 2 times 6 is 12. Oh, by the way, we need to add a 0. So 2 times 6 is 12. We're going to write the 2, carry over the 1. And 2 times 3 is 6, plus 1, that's 7. So now we need to add these numbers. Don't forget to add the 0 because I almost forgot to add it. 4 plus 0 is 4. 2 plus 2 is 4. 3 plus 7 is 10. So 29 times 36 is 1044. So that's how you can multiply using the old school method. Now there's a lot of other techniques that we could use to perform multiplication. Another one is the distributive property. We could write 29 as being 20 plus 9. And 36 is basically 30 plus 6. Perhaps you heard of the expression FOIL. If you haven't, F stands for first. So you want to multiply 20 by 30. Now what is 20 times 30? 2 times 3 is 6. And then all we need to do is add up the 2 zeros. So 20 times 30 is 600. Next, we have 20 times 6, which is 2 times 6 is 12. Add the 0, you get 120. And then 9 times 30. 9 times 3 is 27. So 9 times 30 is 270. And finally, 9 times 6 is 54. So you can see how the word FOIL works. This is first, and then outer, inner, last. Now let's add up these numbers. So I'm going to line them up. We have 600, and then 270, 120, and 54. So this is going to be 4. 2 and 7 is 9, plus 5, that's 14. Carry over the 1. 6 and 1 is 7, plus 2, that's 9, plus 1 is 10. So we get the same answer, 1044. So that's another way in which you can multiply two numbers using the distributive property. Now, there's some other techniques that you might have seen before. Another one is called the area model multiplication. 29 is a 2-digit number, and 36 is a 2-digit number. So what we're going to do is we're going to create a table with 2 rows and 2 columns. So we could put the first number on top. 29 is basically 20 plus 9. 36 is 30 plus 6. And basically, this is going to be the same as the distributive property, but it's more visual. 30 times 20 is 600. 30 times 9 is 270. And then 20 times 6 is 120. And then 9 times 6 is 54. So if you add these numbers again, you're going to get the same result of 1044. Now another technique is known as lattice multiplication. So what we're going to do is we're going to draw another table with 2 columns and 2 rows. Now we're going to write the numbers differently. Instead of writing 20 and 9, we're going to put 2 and 9. And instead of writing 30 and 6, we're going to write 3 and 6, but on the right side instead of the left side. Next, draw diagonal lines. Now what we're going to do is we're going to multiply. So let's multiply 9 by 6. 9 times 6 is 54, but the way we're going to enter it, we're going to write it as 5 and 4. Next we have 9 times 3, which is 27, but we're going to write it as 2 and 7. And here we have 2 times 3, which is 6, but we're going to write it as 0, 6. And then finally, 2 times 6 is 12, so we'll write that as 1, 2. And then what you need to do is add. So let's put another line here. So we're going to add the numbers in each diagonal. And you need to start from this side. Here we have only 4. My computer's acting up. It's behaving slowly right now. And then here we have 7 plus 5, which is 12, plus 2, so that's 14. We're going to write 4 and then carry over the 1. 2 plus 1 is 3, plus 6, that's 9, plus 1 is 10. So we're going to write 0, carry over the 1, and over here, we just have a 1. Now, you need to read it this way. So as you can see, the answer is the same, 1044. So far, we explained multiplication as repeat addition. But there's something else that can help you to multiply certain numbers. And if you can visualize math, math becomes a lot easier to understand. And let me illustrate that. Let's say if we wish to multiply 20 by 17. What is 20 times 17? Now, you could use any one of the techniques that we've discussed so far. But there's also another way of getting the answer. Now, what's 2 times 17? 17 plus 17, if you add it twice, you get 34. So 20 times 17 has to be 340. That's one way to think about it. But let's see if there's any other ways. Now, what I want you to do is imagine if you have 17 $20 bills. So let's draw a picture. So here's the first $20 bill, here's the second one, here's the third, fourth, and here's the fifth one. So that's 5 20s. So here we have 10 20s now. So let's draw another set of 5. So that's 15 $20 bills. So now we have a total of 17 $20 bills. And that's what we're doing. We're adding 20 17 times. Now we know that 5 20s will give us 100. And 2 20s will give us 40. So thus we have a total of $340. Thus multiplication can be made easy if you can visualize it using money. Now let's talk about division. What is division? Like really, what is it? Division is the opposite operation of multiplication. It's basically the reverse of it. So for instance, let's say if we wish to multiply 9 times 4. If you add 9 4 times, this will give you 36. Well, the reverse is true. 36 divided by 4 is 9. Or we could say that 36 divided by 9 is 4. And so you could see that division is basically the reverse of multiplication. So with that in mind, what is 42 divided by 6? So 6 times what number is 42? Now, if you're familiar with your multiplication tables, you know that 6 times 7 is 42. Therefore, 42 divided by 6 will give us this missing number 7. And so when you're dividing, just think about the opposite of multiplication. Here's another example that you could try. What is 56 divided by 7? So 7 times what number is equal to 56? Or how many times should we add 7 to get to 56? It turns out that 7 times 8 is 56. So thus 56 divided by 7 is 8. Now let's try this example. 28 divided by 4. What's the answer? So let's think about this another way. So we need to break down 28 into 4 equal parts. So what number, when added 4 times, will give us 28? To get a visual illustration of this, let's draw a rectangle. And let's say that the rectangle is 28 units long. So if we divide this rectangle into 4 equal parts, what is the length of each smaller rectangle within the larger rectangle? Well, if you break down 28 into 2 equal parts, you're going to get 14. 14 is half of 28. And then if you take half of 14, you get 7. So you can break down 28 into 4 equal parts of 7. So we have 7 plus 7 plus 7 plus 7 is 28. So thus 28 divided equally into 4 parts is 7. So that's another way in which you could think of division. Here's another one. What is 40 divided by 5? So if we divide this rectangle into 5 equal parts, what is the length of each part? So what number, when added 5 times, gives us 40? This is going to be 8. If you add 8 5 times, it's 40. So when you divide 40 into 5 equal parts, you're going to get 8. So hopefully this helps you to conceptualize the concept of division. Here's another one that you could try. What is 168 divided by 4? So if you divide 168 into 4 equal parts, what will you get? Another technique that you could use when dividing numbers is to write it as a fraction. So 168 is the numerator of the fraction, 4 is the denominator of the fraction. And if you think about it, if we divide 16 by 4, that's going to give us 4. And if we divide 8 into 4 equal parts, that will give us 2. So 168 divided by 4 is 42. Now, not every division problem works out as nicely as that one. For instance, let's try this one. 96 divided by 6. So let's write it as a fraction. Now, 6 doesn't go evenly into 9, so we can't do that. But in a situation like this, what you could do is break down 96 into smaller numbers. I would break it down into 60 because 6 goes into 60 nicely. 30 and 6. 60 plus 30 is 90, and then plus 6, that's 96. Now when you have a fraction like this, you could separate it into smaller fractions. So we could say it's 60 divided by 6, 30 divided by 6, and 6 divided by 6. Now 60 divided by 6, if you divide 6 by 6, you get 1, and then you add the 0, so that's 10. 30 divided by 6 is 5, because 6 times 5 is 30. And for the last one, 6 divided by 6 is 1. So we have 10 plus 5, which is 15, plus 1, that's 16. So 96 divided by 6 is 16. Now let's try another example. Let's divide 216 by 8. Go ahead and work on that one. So let's turn this into a fraction. And let's break it down into smaller fractions. So what numbers should we decompose 216 into? Since the denominator carries an 8, I would prefer to use 80 because 80 divided by 8 is 10. Now we're going to need another 80. 80 can go into 216 at least 2 times. So right now 80 plus 80 is 160. We need to keep adding until the numerator adds up to 216. That is all the numerators of these fractions. So I'm going to use 40 because I know what 40 divided by 8 is. So this is 160 plus 40, that's 200. I need 16 more to get to 216. And so now this equation is balanced. So this is 160, 200, 216. The left side is equal to the right side. So now I can divide. 80 divided by 8 is 10. And so we have another 10. 40 divided by 8, we know it's 5. And 16 divided by 8 is 2. 10 plus 10 is 20. 5 plus 2 is 7. So we could say that 216 divided by 8 is 27. And so that's another way in which you could divide two numbers. Now let's confirm our answer using long division. So let's put 216 on the inside and 8 on the outside. How many times does 8 go into 21? If we add 8 multiple times, we get these numbers. Eight times 1 is 8. 8 times 2 is 16. 8 times 3 is 24, and so forth. So based on that table I have on the right, how many times does 8 go into 21? 8 goes into 21 2 times. 3 is too much because 24 exceeds 21. So let's put a 2 on top. Now we need to multiply. 8 times 2 is 16. And then we need to subtract. 21 minus 16 is 5, and then bring down a 6. Now how many times does 8 go into 56? We know 8 goes into 56 7 times. 8 times 7 is 56. And so we have a remainder of 0. And as you can see, this is our answer right here. So 216 divided by 8 is indeed 27. Let's try a harder example. Let's divide 1302 by 7. Feel free to use any technique that you wish to get the answer. Now I'm going to use two techniques. The first of which is going to be long division. Now how many times does 7 go into 13? 7 goes into 13 one time. And so we can write 7. 7 times 1 is 7. And then we need to subtract. 13 minus 7 is 6. And then we need to bring down to 0. Now how many times does 7 go into 60? If you're not sure, I recommend making a list of the multiples of 7. And ideally, you want to get up to 70. You really don't need to get past that. You basically need the first 9 multiples of 7. So this is 1, 2, 3, 4, 5, 6, 7, and so forth. So notice that 63 exceeds 60, but 56 is just under it. So we could say that 7 goes into 60 8 times. And then 7 times 8 is 56. 60 minus 56 is 4, and then bring down a 2, and we can see that 7 goes into 42 6 times. And so having that table on the right, it makes long division a lot easier. And this is our answer. So 1302 divided by 7 is 186. Now, let's use another technique to get that same answer. There's something called the box method for division. And we're going to use that here. So I'm going to put a 7 on the left side. Now, if you divide 1302 into 7 equal parts, you're going to get a number that has 3 digits. So I'm going to put 3 columns in this rectangle. Now, I'm still going to set up the problem like this. How many times does 7 go into 13? We know that 7 goes into 13 one time, but this 13 is really 1300 or 1300. So 7 goes into 1300 basically 100 times. And if we multiply 7 by 100, that will give us 700. Now let's subtract 1302 by 700. And so that gives us 602. So how many times does 7 go into 6? 7 doesn't go into 6, so we need to consider 60. How many times does 7 go into 60? 7 goes into 68 times. So if 7 can go into 68 times, 7 can go into 680 times. If 7 times 8 is 56, 7 times 80 is 560. So now let's subtract 602 by 560, and this gives us 42. 7 goes into 42 exactly 6 times. 7 times 6 is 42. And if you add these numbers, 700, 560 plus 42, they have to give you 1302. But our answer is the sum of these 3 numbers. 100 plus 80 plus 6 is 186. And so that is the box method for division. And as you can see, there's a lot of different ways in which you can add, subtract, multiply, or divide. But basically, you need to understand how it works and pick a method that is suitable for you. So that's it for this video. Thanks again for watching, and I'll hopefully see you in the next video.